Okay, let's talk about transformations of functions. So essentially, the transformations of functions, it just means that we're taking functions and we're going to be moving them left, right, up, down, flipping them, and we're not going to really talk about shrinking them or stretching them. But before we start moving them around, we need to become familiar with the three basic functions we're going to be talking about. So we're going to be talking about parabolas. So f of x equals x squared. Whenever you see this x squared, you're thinking parabola. So y equals x squared is a parabola. Its vertex is at the origin, so it's 0, 0, and it's a U shape that faces upward to the left and right. That point at the origin, that vertex, is going to be what we're tracking whenever we are doing our transformations. For absolute value, so if you see f of x equals absolute value of x, or y equals absolute value of x, that looks like a v. And again, it's going to touch at the origin, and that's the point that we will be tracking whenever we do our transformations. And the square root, so f of x equals the square root of x, or if you see something like y equals the square root of x, this is actually half a parabola on its side. So one of the things I've had a student point out to me is that this shape, so that half a parabola on its side, is very similar to this part of the radical sign. So if you can, try to use that to remember. Also, for absolute value, the v in value looks like the v on the graph. So first we're going to talk about vertical shifts, so moving things up or down. So whenever I go through and explain this, I'm going to talk about things in terms of being with the x or not with the x. For vertical shifts, we'll be talking about numbers that are not with the x. And what I mean by that, since our three main graphs are going to be parabolas and absolute value and square root of x, or half a parabola on its side, to be with the x, it would have to be in here with the x, so in parentheses with the squared. It would have to be within the absolute value bars with the x, or underneath the radical with the x. However, having a number outside of the x, these are going to be vertical shifts. So these are outside or not with the x. And if it's not with the x, it is exactly what it looks like up or down. So for this first one, we will be taking our parabola, or the graph of x squared, and moving it up 2. For this second one, we would take the absolute value of x, that graph, or that v, and we would drop it down by 3. And for the square root of x, or that half a parabola on its side, we'd be moving that entire graph just up 6. So let's look at a couple of these. So here we have the x squared minus 2. You have to know the basic shape. And so the basic shape for that is just going to be the parabola. So this would be your x squared. The x squared minus 2, this minus 2 is going to drop it by 2. So we're going to take this point, 0, 0, drop that down by 2, and that's going to be the one that's easiest for us to track. So the parabola is just going to drop down. For the next one, the absolute value of x, again, you need to know the basic shapes. The absolute value, that v in value, reminds you that it's going to be a v. And again, that point 0, 0 is the one we're tracking. So if this is the absolute value of x, plus 3, that is not with the x, is going to raise the entire graph up by 3. So this plus 3 means it's going to go up 3. So from here, we're going to go 1, 2, 3. And there's going to be the absolute value of x plus 3. My graph's a little off. I'll try to straighten it just a little bit. All right, still not great, but you get the idea. All right, and then for our g of x equals the square root of x plus 2. Again, you need to know the shape of the square root of x, and again, half a parabola on its side. So it's going to look something like that. It's not a great one, but you get the idea. So that is just the square root of x, where it's supposed to be. And then whenever we add 2, this plus 2 is just going to move it up 2. Because again, that is not with the x. So we're going to take that 0, 0 point and go up 2. So that's going to be the general idea right here. All right, now let's talk about horizontal shifts, or shifting our graphs left and right. And this is going to be whenever we have numbers with the x. So remember, your x-axis runs left and right. So whenever you're doing something with the x, we're going to be talking about left and right. So whenever we have something with the x, and again, I'll give a quick example. So if we have something like y equals x minus 2 squared, or y equals the absolute value of x plus 1, or y equals the square root of x minus 2. All of these are with the x. So in this parabola, or in the x squared, instead of being x squared, it's x minus 2 squared. So that minus 2 is with the x, it's in the parentheses. Here, the x plus 1, that plus 1 is within the absolute value bars. And here, the x minus 2, that minus 2 is underneath the radical. So those are all with the x. And again, because it's with the x and x is dealing with left to right, these are going to be dealing with left to right. Now the trick is, if it's with the x, it's the opposite of what it looks like. So this feels like a negative 2, but really we're going to move it a positive, or to the right 2. This feels like a positive 1, which normally that would make us feel like we should go to the right. But instead we're going to go to the left 1. And here this minus 2 feels like we should be going to the left 2, but instead we're going to go to the right 2. So we're going to go to a positive 2. Let's look at a few examples. So here we've got the x minus 1 squared, and again this minus 1 is with the x, it's in those parentheses. So if we start with the basic graph of x squared, this minus 1 feels like we should go over to the left 1, but because it's with the x, it's the opposite of what it looks like. So this minus 1 is actually going to move it to the right by 1. So we're just going to take that point 0, 0 and move it over by 1. Oops, not a very pretty graph, but you get the idea. All right, and then for b, we have the absolute value of x plus 3. Again, that x plus 3, that plus 3 is with the x. So we're going to start with our basic shape. So that v, because we're thinking absolute value, it's the absolute value of x. This plus 3, because that's with the x. We know we're talking about going left or right. This feels like we should go to the right. But again, if it's with the x, it's the opposite of what it looks like. So we're going to go to the left by 3. And there we go. That's going to be our absolute value of x plus 3. For c, the square root of x plus 1, again, we need to know what the square root looks like. So it's going to be half a parabola on its side. That's not a beautiful picture, but you get the idea. So that's going to represent the square root of x. The square root of x plus 1. That plus 1 feels like we should be coming to the right, but because it is with the x, it is the opposite of what it looks like. So we're going to go to the left by 1. So here is going to be your square root of x plus 1. For d, we're going to be doing two things. So we have the square root of x plus 1, which we just talked about here. That plus 1 moved it to the left by 1. And then this minus 1 is not with the x. This minus 1 is not with the x, so it's going to be exactly what it looks like up or down. So this is going to go down by 1. So we're starting with our original graph of our square root of x. And we need to go to the left 1, and we need to go down 1. So that's going to be our new graph of the square root of x plus 1 minus 1. All right, let's talk about reflecting. So again, we're going to stick with the idea of things being with the x or not with the x. So if you have a negative in front of everything, so that is not with the x, then that's going to be reflecting things up or down. And I will typically say flipping things up or down, but really it's reflecting over the x-axis. What I mean by that is if we had something like this, and we said that that was f of x, so y equals f of x. If I would made the negative in front of everything, then that would flip it down or reflect it over the x-axis. So it's going to look like this, and that's going to be y equals negative f of x. Well, the other thing to consider is if we have a negative with the x. So if it's with the x, remember, x is dealing with left and right. So if we put a negative with the x, it's going to flip it left and right. So we're going to start with this y equals f of x. So if we do y equals f of negative x, it's going to reflect over the y-axis, or it's going to flip it left and right. Now, we aren't going to have to think as much about reflecting as we are flipping, because our three main graphs all have a point at the origin. So flipping and reflecting are essentially the same thing. However, if you're not dealing with one of our three main graphs, three main functions, then you will need to know that you're going to be reflecting over the x-axis or the y-axis, or reflecting it up, down, or reflecting it left, right. Also, whenever you're doing transformations, if there are multiple steps, make sure that you do the reflecting first, then do the rest of the transformation. So here with A, we have negative x squared. So again, remembering that our x squared is going to look similar to this. That negative is not with the x. That negative is in front of the x. If it was with the x, then we would have had h of x equals negative x squared. We're going to come back and talk about that in just a second, but first let's do this one. So for this negative x squared, the negative is in front of the x, so we're going to flip it up or down. So all we're going to do is take this, and we are, again, flipping it down or reflecting it over the x-axis. So this is going to be your negative x squared. If we had the parentheses and had the negative inside the parentheses, negative x squared, putting the negative with the x means that we would need to flip it left and right or reflect it left and right. However, whenever you do that, because there is symmetry, if you flip it left and right, it's going to land on top of itself. So this is exactly the same as just the x squared. So the green here would represent just x squared, as well as parenthesis negative x close parentheses squared. All right, for B, again, we need to know our general shape that we're starting with. So square root is going to be half a parabola on its side. And we need to do the reflecting first. This negative in front, so in front means that we're going to reflect up and down. So this is going to flip this down or reflect it up and down. And then this plus 1 here, plus 1 is with the x. So if it's with the x, it's going to do the opposite of what it looks like to the left or right. Plus 1 feels like it should go to the right, but because it's with the x, it's the opposite. So it's going to be left 1. So we need to flip this over. So whenever we flip it, so there's our first step. And then our next step is to move it to the left 1. So we're going to end up right here. Okay, let's look at the absolute value. So again, remember the basic shape. So we're starting out with the V for absolute value. And now let's go through and talk about what all of these do. So this negative is not with the x, it's in front. So this is going to flip it up or down. This plus 4, that is with the x, so it's the opposite of what it looks like. So that's going to move it to the left by 4. And then this plus 2 right here, that is not with the x. So it's going to be exactly what it looks like up or down. So this is going to move it up by 2. So we need to flip this over. So that's our first step, is to flip it over. And then we need to move it. So we need to go to the left by 4. And then up 2. So this is going to be where we end up. All right, let's look at one more example. So we have negative and then parentheses x minus 1 all squared plus 2. That squared lets us know we're dealing with a parabola. So that kind of U shape. And again, the vertex is going to be at 0, 0. So this is our basic shape. And now let's talk about what everything does. This negative here is going to flip it up or down. And then this minus 1 is with the x, so it's the opposite of what it looks like. So we're going to go to the right, 2. And then this plus 2 is not with the x, so it's going to be exactly what it looks like up or down. So we're going to go up by 2. So we're going to start by flipping this down or reflecting it over the x-axis. And then we need to go to the right to the right by 1. Let me correct that. So this minus 1 is we're going to go to the right by 1. So we've moved it to the right by 1, and then we want to go up 2. So we're going to end up right up here. And then I do want to show one more example. If we were to have f of x equals the square root of negative x plus 2, this negative is with the x. So this negative is going to flip it left or right. And again, that's reflecting it left or right. And that plus 2 is not with the x, so it's exactly what it looks like. So we're going to go up 2. So for this, the general idea would be taking our graph, so our square root of x, we would need to flip it left or right, or reflect it left or right. Oops, let's try that again. General idea. And then we would need to take that up 2. So we'd go up 2. We'd end up right there. One more example I want to show, which is probably one of the trickier examples, would be if we have something like f of x equals negative square root of negative x plus 2 minus 3. Now we need to go through and figure out what's going on. The reason this is tricky is we go, oh, well, there's a negative with the x. However, that we need to pull the negative out. So I'm going to rewrite this as f of x equals negative square root, and then I'm going to pull that negative out. So then we're going to have x minus 2 all minus 3. So now we have a negative that is with the x, so it's underneath that radical. We have a negative in front, and then we also have obviously numbers with the x and not with the x. So we can talk about what all of these do. And again, we're talking about our general shape of square root of x, so that half a parabola on its side. So this very first negative sign, that is going to flip it up or down. So just this negative sign, we're only taking that into account, because again, when you do our reflections first, would have it look like this. So it would be negative square root of x. And then this negative is going to flip it left and right. So that's with the x, because x is left and right, and this is with the x. This is going to flip it left and right. So we reflected down, and now we need to reflect this to the left or right. So we're going to reflect this way. And now, so this blue one is where we're at, and that would be the idea of a negative square root of negative x. So I'm going to erase this purple one just to hopefully reduce confusion. And now we need to talk about what this minus 2 and this minus 3 do. So this minus 2, because that is with the x, it's going to be the opposite of what it looks like. So that's going to actually move us to the right 2. And then this minus 3 is not with the x, so it's going to be exactly what it looks like up or down. So this is going to move us down 3. So all we really need to do, after we've done our reflecting, is move to the right 2 and down 3. So I'm going to take this blue graph, I'm going to move it to the right 2 and then down 3. And we would end up right around here. So that would be your final graph for f of x equals negative square root of negative x minus 2 minus 3. All right, let's do a little bit more practice. So we have h of x equals negative x minus 1 all squared. That squared, again, lets us know we're starting with a parabola. Not a beautiful parabola, but you get the idea. So this negative in front, again, it's not with the x, so that's going to be up and down. So it's going to flip up and down. And then this minus 1 is with the x, so it's the opposite of what it looks like. So we're going to go to the right by 1. So we need to take this graph, flip it down, and then we need to move that to the right by 1. For our next example, the square root of x plus 2 minus 1. Again, we're starting with our basic shape of our graph, so that's square root of x. And then we're going to have this plus 2. That's with the x, so it's the opposite of what it looks like to the left or right. So we're going to go left 2. And then we have this minus 2. That is not with the x, so it's going to be exactly what it looks like. So that's going to go down 2. So all we're going to do is take this graph, go to the left 2, and then go down 2. So we're tracking that 0, 0, left 2, down 2. And one more. So we have g of x equals negative absolute value of x plus 4, all plus 2. This negative in front, again, in front, is going to have us flip this up or down. This plus 4 is with the x, so it's going to be the opposite of what it looks like to the left or right. So this is going to be left 4. And then this plus 2 is not with the x, so it's exactly what it looks like, up or down. So this plus 2 is going to move it up 2, since it's exactly what it looks like. So we're going to go up 2. And again, starting with our general shape, so because the absolute value, we're thinking about v. So there's our v shape. And then we will flip it down because of that negative and because we do all the reflecting first. And then we need to move it to the left by 4. And then up 2. And this is going to be where we end up. So again, we went to the left 4 and up 2. And that's after we reflected it down.